In this video, we're going to go through some examples showing you how to factor some trinomials. One of the things that we'll look at is what happens when your trinomial has a leading term other than 1. For a lot of the examples, it's just going to be a 1 in front. So problem number 1 here, example number 1, m squared plus 12m plus 32. So to factor means I want to rewrite this problem as a multiplication problem. So you may have done binomial multiplication prior to this. This is basically undoing that. Okay, so we're going to turn this back into binomial multiplication. So I'm going to draw myself two sets of parentheses. This leading term here, this m squared, I'm going to split. So m in the first parentheses, m in the second parentheses. Now I need to figure out what's going to go inside those parentheses with those m's. So as long as you don't have a number in front, what you can do is look at your c value, if you remember standard equation, standard form, your constant term, and you need to think of two numbers that multiply to that constant, and then I want those same two numbers to add up to be 12. So over to the side here, I'm going to write out what multiplies to 32. So to keep it organized in my head, I always start with whatever the number is times 1. So 32 times 1. And then I'm going to do 2 times 16. 3 does not go into 32. 4 times 8. 5 doesn't go into 32. 6 doesn't go into 32. 7 doesn't go into 32. And because 8's already on my list, I've already got my all of my factor pairs. So now that I know what multiplies to 32, I want to look at each one of these factor pairs and see if they could possibly add up to be 12. There is no way that 1 times 32 is going to somehow add up to be a 12. 2 and 16 are not going to make me 12 either, but 4 and 8 will. So to get a positive 4 here and a positive 8 here. Now, if you wanted to check your work to make sure that 100% you know you did the right thing, what you could do, I'll put this down a little bit lower, is you could take your factors and you could distribute to multiply them together. So m squared plus 8m plus 4m plus 32. These two middle terms will combine. So m squared plus 12m plus 32, which is exactly what we started with. So this, I know 100% is my factored form for that problem. You don't have to do this check. It's just to see, as you're doing a problem, if you want to know if you have the right answer without asking your teacher or a classmate of yours. Okay, so I'm going to move on to the second example. All right. So the first thing I notice is there's no number in front of our leading term here. It's just a 1. So I can do the same process that I just did in the last problem. So I'm looking to multiply to negative 10 and add up to negative 3. Now, if you can immediately figure out what those numbers are, then you can absolutely just write down the two factors. However, if you need a little help, right, I know I'm supposed to multiply to negative 10, but for my factor pairs, I'm just going to go ahead and multiply to 10. So 1 times 10 and 2 times 5. No matter what I do, 1 and 10 are not going to get me a negative 3. And I do know that if I work with 2 and 5, I can get a negative 3. And the way I'm going to do that is to leave the 2 positive and make the 5 be negative. And if you want to double check this, right, in a calculator you could take 2 times negative 5, you get negative 10, which is what we're supposed to multiply to. And if I take 2 minus 5, I will get negative 3. So that 2 is positive, that 5 is negative. There's my two factors. Okay, So let's see if we can keep using the same method or if we have to change methods when we go into the next problems. So problem number 3. Let's get that a little centered in the page there. So what am I trying to multiply to? Well, I'm trying to multiply to my constant, which is 2, and I'm trying to add up to 2. Okay, so what multiplies to 2? Well, the only thing that multiplies to 2 is 1 times 2. And while 1 times 2 does multiply to 2, I can't take 1 plus 2 and make this middle term. So if that happens, and it doesn't happen often with these problems, but here's the deal. Not every expression is factorable. So this particular example is not factorable for what we just tried to do. Okay, there's no GCF. You can't factor the trinomial as it's written, so you're just going to say it's not factorable and move on to the next problem. Now, having said that, please assume if you're given an assignment that has factoring problems that most of the problems will in fact be factorable. So keep trying to look for things, but in this case, the only numbers that multiply to 2 are 1 times 2, and so it's pretty easy to see that that's actually not going to add up to 2, so it's not factorable. All right, fourth little example here. Let's see what we've got. We have the same idea, so in front of our a value, there is no number there other than 1, so we can keep using the same method. We're trying to multiply to positive 21, and I want to add to negative 10. So off to the side, I'm going to write down what multiplies to 21. So 1 times 21 and 3 times 7. Now, one thing that I notice, and I've worked with these problems a lot, so I tend to see the numbers and not the exponents, the numbers and the signs, and know what those mean. So here's what I notice. I'm trying to multiply to a positive, but I'm trying to add to a negative. So the only way that's going to happen is if the numbers that I'm multiplying are both negative. All right? Remember, a negative times a negative will make a positive, and a negative plus a negative will make a bigger negative when you combine them. So if I look at these two factor pairs here, the only one that's going to work is negative 3 and negative 7. So I'm going to go ahead and use those two terms to write my two factors. So a minus 3, a minus 7. And I'm going to make one quick note just in case you are worried or concerned. If you have the factors written reversed of what I have, so my first term is your second, your first term is my second, whatever it is, as long as your signs match, you have the same answer that I do. So remember, order on multiplication doesn't matter, and so that's the same thing with your factors because these are being multiplied together. All right, so that's 4 examples. Let's see what else we've got here. Ooh, wait a minute, because now we're starting to add a number here. Okay, so there's a number in front of this leading term that we absolutely have to pay attention to. So it's no longer, I can't just look at negative 10 and I can't just look at negative 7. I have to pay attention to that number in front. So I'm going to show you 2 different ways to deal with it, and it really is going to depend on what makes sense for you and what you are comfortable with. I use a method called guess and check. I've been using it for years, and basically because I have been using it so long, my number sense with these is pretty decent. So here's what I notice. I know that I have 3m squared. The only way I can make a 3 is if I take 3 times 1. So I'm going to give this 3 an m, and I'm going to give that 1 an m. So if I were to multiply these two together, 3m times 1m, that's going to create 3m squared. Now I need to fill in this value and this value so that 2 things happen. I need to multiply to negative 10, And when I do my distributive property in the binomial, I can also create negative 7m. So let's see how I could do that. Well, let's see. I know that 10 is either 10 times 1 or 2 times 5. So if I do 3 times 1, and there would be a 10 here. Let's make the 10 negative. Let's make that 1 positive, and I'm going to take a second to get rid of those highlighter bits. Now, I know you might be looking at this going, you put those numbers wherever you wanted to, and they could be right, they could be wrong. So this is a place where I would absolutely check my work. So how do I check it? So if I do 3m times 1m, 3m squared. 3m times 1 is positive 3m. Negative 10 times 1m is negative 10m. Negative 10 times 1 is negative 10. These two terms in the middle are like. Positive 3 minus 10 is negative 7m minus 10. Here's my 3m squared. Now, this expression perfectly matches my original expression. So I'm going to take out the little arc marks here because this is the answer. The other work around it, these pieces down here, is just my check. Okay, so that's guess and check, where you'll notice I made a little bit of note off to my side here, but pretty much all the work was done in my head, figuring out what numbers worked together. Okay, sometimes it's handy if you can do it. Other times you need a better method. Okay, so let's say you look at this and you're like, I'm not going to try and guess and check that. Okay, that's fine, don't. So the other method is if you take your A value times your C value. So off to the side here, I'm going to do 7 times negative 9, and that should be negative 63. So what I want are two numbers that multiply to negative 63 and add up to my middle term of negative 2. So let's see, and let's talk about what multiplies to, and again, I'm going to ignore the sign temporarily and just deal with what multiplies to 63. So 1 times 63, 2 is not going to work. 3 times, I believe it's 3 times 21. Give me 1 second to check that. It is 3 times 21. 4, no. 5, no. 6, no. 7 times 9. And that's it. Okay? So now, if I look at these, I don't care what you do to a 1 and a 63. It doesn't matter which sign is which. You're not going to make that to be a negative 2. Same thing with 3 and 21. There's no way to change the signs up enough to make those somehow work out to be a negative 2. So no to that one, no to that one. I do like this bottom pair here. In order to create a negative 2, the larger number has to be negative. Okay? Now, I said this is not guess and check, so we need to know what to do next. So your next step, you're going to take your first term, leave it alone, take your last term, and leave it alone. What I want you to do is take this middle term and split it using these two values. The order that you write them doesn't matter. So I'm just going to go in the order that they're written there. So plus 7p minus 9p. So if you think about it, we have 7p here minus 9p. That would be negative 2p if we were to combine them. But remember, I split them. Now, the reason we split them is so that we can now group them. So you're going to group the first two terms and find a GCF. So these two terms have 7p in common. If I divide it out, what will be left is p plus 1. These two terms both share a common factor of negative 9. So if I take that out, I'd have p plus 1. One quick check that you always want to do with these is make sure that your parentheses sets match perfectly. They cannot be different from each other at all. Okay? So to finish the problem then, you're going to do one final GCF across the whole problem. And the reason you do that is because this and this, right, these little parentheses sets are a common factor to the whole problem. So p plus 1 is what they had in common. 7p minus 9 is what's left. And that is the factored form for that example. Now, you could have done that with a guess and check if your number sense is pretty good and you can think of what multiplies to 7 and what multiplies to 9. You can also do this method using, for that fifth example I showed. Okay, so it really is up to you. This particular method is often referred to as the AC method. So you might actually be able to look it up and see if you can find other examples if you need them. Mathematicians not terribly creative about naming things. The reason it's called the AC method is because you start by multiplying the A value times the C value. So AC method. I hope this has helped give you some examples on how to factor trinomials, whether they have a leading value of 1 or a leading value of some other number.